All right, in this video, we're going to be talking about impulse momentum. All right, so let's go ahead and just first start by talking about what is momentum. So momentum, P, is equal to mass times velocity. So you can actually take your velocity vector, times it by its mass, and you will get the momentum of the object that you're looking at. So again, P is momentum, M is mass, and V is your velocity vector. All right, so if we had a 10 kilogram object and velocity equal 2, -3, 1, find its momentum vector. So go ahead and work this one out on your own. You're seriously just going to take that and multiply it by each of those to get your momentum vector. So yeah, you can pause the video, work that out, and then check your solution with the PDF below. It'll be number 1. All right, so let's talk about a little bit like conservation of momentum. So if you had two objects going towards each other and they eventually collide here, and let's say, for example, once they collide, they actually don't bounce back away from each other, but one of them is moving so much faster than the other one that they actually just stick together and kind of become one object and then move off in one direction. All right, this is called coupling when they stay together like that. All right, and when colliding objects couple, you can actually use this equation right here. So this is going to be mass of object 1, velocity object 1, mass object 2, velocity object 2, mass object 1, mass object 2. Then this is the final velocity of that coupled object right there. So, for example, if we had, let's see, if we had a 10 kilogram block traveling at 2 meters per second, and it hits a 1 kilogram block at rest, and they coupled, we can actually find their final velocity after they coupled. So we would have mass 1 times velocity 1 plus mass 2 times velocity 2 equals mass 1 plus mass 2 times final velocity. So we'd have, this would go to 0 here, so we'd have 20 equals 11 v prime, so v prime equals 20 over 11 meters per second. Right, and that would be the velocity of the coupled object. So go ahead and try one of these on your own. Say you've got, again, a 10 kilogram object and it's traveling at 10 meters per second. and it collides with a 2 kilogram block at rest. Find the final velocity of the coupled object. All right, go ahead, pause the video, work that out, and then check your solution with number 2 in the PDF. All right, now if objects don't couple, they actually have this thing called, it's called E, but that's your coefficient of restitution. And I kind of like to think about this as how much bounce the two objects have. So if you have colliding objects, it's kind of, if they are really springy and bounce back really far, then that is what's called being perfectly elastic. And your E would be equal to 1. Now, if they don't have a tendency to bounce back away from each other and they stick together, like we were talking about that coupled thing, then they are plastic or perfectly inelastic, and E equals 0. All right, and anywhere in between is kind of in that range between plastic and perfectly elastic. But we can actually figure out the coefficient of restitution of objects when we know the final velocity of object 2, final velocity of object 1, and then the initial velocities of object 1 and 2. So again, remember, if it's got this little prime on it, that's a final velocity. If it doesn't have a prime, that's an initial velocity. All right, so for example, if we know two objects collide and let's say the initial velocity for one equals 10 meters per second this direction, v2 equals 2 meters per second this direction, and then the final velocities are gonna be 6 meters per second that way and 1 meter per second that way. You just go ahead and plug these into this equation here. So we'd get 6 minus 1 over 10 minus 2. Now you've got to be careful here because these directions do matter. So I'm going to declare this direction to the right as being positive. So this one's actually going to be negative right here. So we're going to have a minus a negative 2. So this ends up being 5 over 12, which when you plug that into your calculator, you'll get coefficient of restitution of 0.42. All right, let's go ahead and try one of these on your own. Let's see. Let's do V1 equals 20 meters per second this way. V2 is 10 meters per second this way. V1 prime is going to be 7 meters per second this way, and V2 prime is now 9 meters per second that way. go ahead and find that coefficient of restitution. All right, so now the last thing we want to talk about, if you know the coefficient of restitution, you can actually find final velocities of two objects colliding. So I'm just going to go ahead and write these equations out for you really fast. So M2, V2, 1 plus E plus M1 minus E M2 V1 over M1 plus M2. And then V2 prime would be M1 V1 1 plus E minus E M1 minus M2 V2 all over M1 plus M2. All right, so I'm not going to do one of these examples with you because it's mostly just taking numbers and plugging and chugging. But you can go ahead and do one of these on your own. So here are those equations again if you want to take a screenshot of that or copy those down really fast. You can go ahead and pause the video and do that now. All right, so go ahead and try this example on your own though. Let's see. It's going to be number 4 in the PDF found below this video here. Go ahead, instead of me just writing it out, go ahead, look it up. Don't look at the answer. Try to work it out on your own and then look at the solution and see if you get it right. See if you can pull out the important information from kind of that story problem and see if you can do it on your own. All right, so that's pretty much it for impulse momentum.